For this lesson, we're going to be looking at more examples of evaluating limits algebraically, particularly in cases where we are looking at a discontinuous point on our function. So, first example, there's no actual really new stuff happening, just some more examples. So, first example, if we have an x to the fourth minus 1 over x minus 1, okay, is our f of x, and we want to take the limit as x approaches 1 of f of x. So this is the limit as x approaches 1 of x to the fourth minus 1 over x minus 1. This is equal to the limit as x approaches 1. So our first trick is we have a rational function here. We're going to try factoring. So this is x squared minus 1 times x squared plus 1 over x minus 1. Now the x squared minus 1 is going to factor further. This is equal to the limit as x approaches 1 of x plus 1 times x minus 1 times x squared plus 1. All of that over x minus 1. Lo and behold, we have an x minus 1 that cancels. Okay, so here we get the limit as x approaches 1 of x plus 1 times x squared plus 1. So this is equal to 1 plus 1 times 1 squared plus 1, which equals 2 plus 2, which is equal to 4. All right, not so bad. So let's look at another example. And these are just kind of all stuff we've done before, just all mixed up. So we have 8x minus 4 over 2x plus 6. And we're going to take the limit as x approaches infinity. And if we don't write anything next to the infinity, we assume that it's the limit as x approaches positive infinity. So this is equal to the limit as x approaches positive infinity. We're going to, remember, divide by the highest power of x, divide each term by the highest power of x in the denominator. So this is 8 minus 4 over x over 2 plus 6 over x. This, as we approach infinity, is going to go to 0. Anything with a variable in the denominator will head for 0. And so this is going to give us the limit as x approaches infinity of 4 is equal to 4. Okay, let's look at another infinity one, because those are the most recent ones that we've taken a look at. So we have the limit as x approaches positive infinity again of 3x squared minus 4 over x squared plus 5. So this is equal to the limit as x approaches positive infinity. Again, we're going to divide by x squared. So of 3 minus 4 over x squared over 1 plus 5 over x squared. Anything with an x in the denominator, squared or not, is going to 0. So this gives us 3, and I forgot to write my limit in. It's got to be in here until the point where I'm plugging in my infinity. So that's equal to 3. Okay, example number 4. Okay. So we are going to try the limit as x approaches 0 from the positive side of 1 over x minus 1 over x squared. We're going to take the limit of this whole thing. So clearly, as we're approaching 0, this isn't going to work. The first thing we're going to try to do is we're going to try to get this into a single fraction. So I'm going to multiply by x over x so that we can actually just rewrite this as one fraction. So this is the same as the limit as x approaches 0 from above, or from the right-hand side, of x over x squared minus 1 over x squared. Okay, so this is the limit as x approaches 0 plus of x minus 1 over x squared. So when we plug in 0 plus, we look at this as a single fraction. This is going to give us 1 over 0, okay? And so this is not indeterminate. We know that this is not indeterminate. Okay, sorry, that's a negative 1 over 0. This is not indeterminate. We know that this means the limit doesn't exist, but we're going to try to describe it by seeing if it's going to positive infinity as we approach 0, or if we're going to negative infinity. So are we trending up, or are we trending down at that vertical asymptote as we're approaching from the right-hand side? So when I plug in 0 plus, I get 0, something slightly bigger than 0 minus 1 is going to be something slightly bigger than minus 1. And something slightly bigger than 0 is going to be something slightly bigger than 0. So we have a negative over a very, 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 very small positive. So this is going to go to negative infinity. So the limit does not exist, but we're using the shorthand saying that it is negative infinity because that means that it's as we approach from the right-hand side, the y values start to decrease and continue decreasing infinitely. Okay, so let's take a look at example number 5. Okay, and just one last note on this question. You notice if I were to plug in 0 here, I would get positive infinity minus positive infinity. We don't do this. We're not allowed to do infinity minus infinity is not equals 0. We have to be very clear about that because infinity is not a number. So if I take infinity and subtract infinity, I have no idea what I've just gotten. So we can't say that that's equal to 0. It is something where we're going to need to do a little bit more work to be able to tease out what's happening in that situation. Okay, example 5. Let's see if I get x. We'll take a lovely function. Let's write what limit we're taking first. So the limit as x approaches 9 of x minus 9 over radical x minus 3. So when I plug in 9, I get, so 9 minus 9 equals 0, and radical 9 minus 3 also equals 0. So I get a 0 over 0, so this is indeterminate. Notice I don't write it's equal to 0 over 0 because we don't know what 0 over 0 is either. So first thing I'm going to do, limit as x approaches 9. I see a radical. If I see a radical, I am going to multiply by the conjugate of the radical expression. So that is the same as radical x plus 3. We want to get rid of that radical or just do something about it. And multiply by radical x plus 3. And remember that we got to put brackets around everything because we are going to expand our brackets properly. So this is the limit as x approaches 9. And I'm honestly just going to leave that numerator right the way it is. I'm not going to expand it just yet because I'm hoping that something's going to cancel. That's the whole idea. So I'm x minus 9 times radical x plus 3 all over x, positive x, minus 3 root x, plus 3 root x goes away. Point, that's the point. Minus 3 times 3 is minus 9. So I get x minus 9 and an x minus 9, and I can cancel. And that's why we did that. So now I'm going to take the limit as x approaches 9, which is radical 9, 3 plus 3. So this equals radical 9 plus 3, which equals 6. And that worked out very nicely. Okay. So example 6. We have the limit as x approaches positive infinity of 5x plus 7 over 3x squared minus x. Okay, so I'm going to multiply by 1 over x squared over 1 over x squared. Okay, so that gives me 5 over x plus 7 over x squared and we are still taking the limit here of x as x goes to infinity, plus 3 minus 1 over x. So everything with an x in the denominator goes to 0, and I end up with 0 in the numerator and a 3 in the denominator, so this is going to be equal to 0. And as you can see, as I'm going through the limits, I am doing some of them kind of vertically, so we're going down, and I'm doing some of them horizontally. It's really your personal preference what you do. If you're writing a test or a quiz or a worksheet that has limited space, sort of up to you. Just please do make sure that you keep your limits here, and that everything, if you're writing a chain of equals, you really do have to make sure that at every stage of the way it really is equal to what you had before. Okay, let's do one that's a little more complicated now. What if we had the limit as x approaches negative infinity of radical 5x squared plus 8 over 2x plus 1. Well, if I just plugged in negative infinity, I would have like a negative infinity squared over an infinity in the square root of that. I don't know what's going on with an infinity divided by an infinity. I can't say infinity, just like I can't say infinity minus infinity is 0. We can't say infinity divided by infinity is 1, because infinity, it's true for any number, but infinity continues not to be a number. So we can't treat it like a number or do things with it that we could normally do with a number. So we're going to have to multiply. We want to multiply the denominator by 1 over x. Okay? So now what I need to do is think back to what do I have to do in the numerator to multiply by 1 over x? Well, I can multiply by 1 over x, but I want to get it under the square root. So I want to rewrite 1 over x as something using a root. So I want to write it as radical something. Okay? So if x were positive, I would write 1 over x is 1 over radical, don't need an extra radical, radical 1 over x squared. Okay, because if I square something and take the square root. The problem is, I know that 1 over x here, because we're going to negative infinity, so 1 over x here is going to be less than 0. So in order to actually keep this equal, something that's less than 0 can't be equal to something greater than 0. This is equal to the absolute value of x, of 1 over x. So we don't want the absolute value, we want the negative of the absolute value. So I'm going to put the negative in front, because I know this one is, I know the left-hand side of the equation is negative. I know the absolute value is the same, but I want the right-hand side also to be negative. So this is going to be negative radical 1 over x squared. Okay? So now I'm going to go and I'm going to multiply this through. I need brackets in the bottom. So this is going to be the limit as x approaches minus infinity. The negative can't go under the radical. It's going to come right out front of negative radical 5 plus 8 over x squared. Notice that stuff all stays positive because the negative can't go under the radical. And then down here we get 2 plus 1 over x. Okay, so this one is going to head to 0. That one is going to head to 0. As we plug in negative infinity. It doesn't really matter whether it's heading to it in a positive or negative way, because it's still going to be 0. So this ends up being equal to negative root 5 over 2. Okay. So let's do another radical one. I know you guys were just really excited about doing radicals, and I've saved the hardest and best one for last. This is not the last one. The next one is really going to be quite fun. So this one is okay. So we've got the limit as x approaches 0 from above of radical x plus 4 minus 2 over x. So we see a radical. What do? We multiply by the conjugate. So this is the limit as x approaches 0 from above of radical x plus 4 minus 2 over x times radical x plus 4 plus 2 over radical x plus 4 plus 2. Okay? And we do need to do something because as we could see up here, if we plug in 0, we get 0 over 0. It's not equal to 0 over 0, but we do get 0 over 0. We can't deal with that. So this is the limit as x approaches 0 plus. And that's actually a good step. I noticed I didn't do it right in the beginning of this problem. It's important before you go off and start doing all your math and your limit stuff, do check and make sure that you actually have a 0 over 0 situation, or a situation where you actually need to do some work, because if you just plug in the number that you're taking the limit as x approaches and you get an actual number, then you're done and you didn't need to do any of that math, and it's more likely that you make a mistake doing all that math. So make sure that you do that first so that you don't end up in a situation where you've just done a lot of math you didn't need to do. Okay, let's expand these brackets. Numerator, we get x plus 4 minus 2 root x plus 4 plus 2 root x plus 4 goes away, minus 4. In the denominator, we get x times root x plus 4 plus 2. Okay, our minus 4 plus 4 is going to cancel, and we also notice that our x's right here are going to cancel. So if everything cancels away from the numerator, this makes this the limit as x approaches 0 from above of 1 over radical x plus 4 plus 2. So now, when I plug in 0, I actually get a something. So 0 from above, doesn't really matter if it's 0 from above or 0 from below. I plug in 0, we get 4, and root 4 is 2. 2 plus 2 is 4. So this is equal to 1/4. All right, as I told you, I saved the best for last. So let's look at this one. So we have the limit as x approaches infinity of radical 2x squared plus 5 minus x. Okay, so when we look at this, if I were to just plug in infinity, what do we get? We get infinity squared, the square root of that, that's going to be infinity. And we're going to be subtracting infinity. So we have like a plus infinity minus a plus infinity. Now, if it were a plus infinity minus a negative infinity, we might be cool, because that would give us a just a negative, so a positive really big number plus another positive really, really big number is just going to be a really, really big number. So that would just be plus infinity. But remember, plus infinity minus plus infinity is not equal to 0 because it's not actually a number. So we have to do something. So we're going to do something that I'm sure some of you would never voluntarily do in your lives. And we are actually going to take this and give it a fraction even though we don't have a fraction. Because we would say, oh, let's multiply by the conjugate. We can't, because this isn't an equation, we can't just multiply by the conjugate. We can only multiply by the conjugate over the conjugate. So we're going to do that. We're going to multiply by the conjugate over the conjugate. So root 2x squared plus 5 plus x over root 2x squared plus 5 plus x. So we have to give this a denominator, even though we didn't have a denominator before. That is okay. So the limit as x approaches infinity. Okay, so we now have, we're going to expand the top, so we get 2x squared plus 5 minus x squared. So this is just going to be x squared plus 5 in the numerator. And the denominator is going to be all of our lovely conjugate, radical 2x squared plus 5 plus x. Now, we are going to want to multiply by the highest power in the denominator. So the highest power in the denominator is, we have an x squared under the radical. So what do we want to do? Well, we need to get a x squared under the radical. What I'm going to do is I'm going to multiply by 1 over x. Okay, so this is still plus infinity over plus infinity. So I am going to multiply by 1 over x. And I actually, right here, so I have a 1 over x. Why am I multiplying by 1 over x? Because it's the highest power in the denominator. So we have 1 over x times 1 over x. So this gives me the limit as x approaches infinity of x plus 5 over x. Now, the denominator gets a little bit trickier. The 1 over x here, remember, 1 over x is equal to radical 1 over x squared. So that's going to get rid of our x squared under that radical sign. And here we don't need to worry about making it negative because x, we're going to positive infinity, so 1 over x is definitely going to be greater than 0. So we don't need to worry about it being negative. So this is going to be, so whatever goes underneath is going to be radical 1 over x squared. So this part will be times radical 1 over x squared, the radical part. So this is equal to 2 radical 2 plus 5 over x squared plus x over x is just 1. So let's see what happens. We go to 0 here. We go to 0 here. We have a radical 2 plus 1 in the denominator, and then we have an x as x goes to positive infinity. So this goes to positive infinity over root 2 plus 1. Positive infinity over any number is just going to go to a plus infinity, and that is where that is going. So that means that that function will actually continue to increase as it gets bigger and bigger and bigger. Okay, hope you enjoyed that last problem. I thought it was a lot of fun, and we'll continue next time with trig limits.